And really the way I like to introduce Isabelle is that she's been doing machine learning challenges way before it was trendy. Now there are so many out there, but really she's one of the pioneers there. That's just from the context of doing challenges and organizing them successfully. She's also an accomplished researcher. She worked at AT&T Bell Labs before being an independent consultant. And there actually she pioneered applications of neural networks. She just some talks about neural networks right now. And she pioneered those applications of neural networks to parent-computer interfaces. And she's also one of the co-inventors of support vector machines, SVMs. So she also has many awards from industry, including Microsoft, Google, and Pesah instruments. And she has organized many challenges, learning challenges with the European network Pascal, with National Science Foundation and Docker. And last but not least, I'm also very excited to work with Isabelle because she's our main partner in this platform that hopefully you'll be able to use successfully tomorrow, which is called CodaLab. We're going to do a competition. And she's really the leading designer for the competition platform. And now let me introduce, and so let's welcome her first. And then let me introduce Olga Yakovic. For Isabelle, it's easy. She's French, so I know I pronounce it correctly. Yakovic. So she tells me that she comes from Minsk, Belarus. And but she's been with us in Seattle for quite a few years. She's actually a senior developer engineer at Microsoft, and she's worked on various products, very successful products, such as SQL, SQL Server Analysis Services, also Power BI, and another product which is Office 365. More recently, about a year and a half actually, she joined a team which is called Azure Manager, and you will hear more about what this team does tomorrow morning with a lecture from her. So for now, let's also welcome Olga. And we start with Isabelle.
Thank you very much. So thank you all for coming up on this long day. And I would like to give you the good news that you won't just be sitting here and listening to talks. You're actually going to be very active and participate in designing new algorithms and try to beat state-of-the-art performance against professional machine learning specialists. And in order to do that, we're going to train you to enter the Automatic Machine Learning Challenge, which is presently ongoing and which will still be running several months, at least until next January. And we're thinking of sliding the schedule to run it until next spring. So you still have plenty of time to try to enter it and beat the state of the art. So this challenge is now working on the CodaLab platform. It's co-developed with Microsoft and Stanford University. And today we're going to have several co-workers that are present here. Lukasz, Romaszko, out of Pesah, and Olga who's going to help today with preparing you by giving you a Python tutorial. And we would like to thank all the sponsors, and more particularly Microsoft, who has been really the main driver of this effort. A lot of people have been helping. And we're particularly grateful to all the people who formatted data, because without data, we couldn't do anything, and we formatted 70 data sets, of which we selected 30, which are going to be used in this challenge. And I would like to also thank all my colleagues at ChaLearn who put in a lot of effort. Now, what is the setting of this challenge? So, the dream of, I would say, every machine learning researcher is to create the perfect automatic machine learning black box. And what I mean by that is that you have some training data and you input it into a machine, and usually it means that you put it into a computer that has some programs running on it. And then out comes the trained model, and now it's ready for some queries and give some answers. So in the previous lecture, for example, you saw that you can train convolutional neural networks to do pattern recognition. So for example, to annotate images, to recognize presence or absence of certain objects, and even do more complicated things like recognizing objects in context or people performing tasks, etc. Now, the reality is that there's a lot of human intervention. There's a lot of kind of black magic behind that, and we call that hyperparameter tuning. So for neural networks, for example, well, you may have a ready-to-use package to do neural networks, but you still have to figure out what the architecture of the neural network is, how many hidden layers, how many units per layer, what kind of activation function, maybe even what kind of objective function, and you have to also decide that whether or not you're going to be using recurrent networks, and maybe you want to combine with hidden Markov models, and also, well, we haven't told you, but you needed to pre-process the data also. Maybe you need to normalize the data, do some dimensionality reduction, because you have some limited compute power. Maybe you have to do some data cleaning, etc., etc. So all of this, we lump it into the broader framework of saying hyperparameter tuning. We lump a lot of things into hyperparameter tuning. What we mean is, all the different settings that you can choose from and that involve manual intervention. And that includes eventually also choosing the particular method that you're going to use in a bigger toolkit. Are you going to be using SVMs or neural networks or decision trees or name it? And what you have to be aware of is that nowadays, being a machine learning researcher is not so much anymore about inventing new algorithms. Very often it is about knowing how to efficiently use other people's code, how to modify other people's codes, how to incorporate other people's codes into a bigger system that you're designing. So this is where we're going to take things from. We're going to actually be using a toolkit called ChaLearn, which is a Python toolkit, which is very much used by challenge participants. And we want you to try to figure out how to remove the human in the loop. How could it be made that there is an ideal program that takes ChaLearn and knows how to figure out how to design the best possible learning machine for a new data set that you've never seen before and without any human intervention. So what we've been doing at ChaLearn over the years is that because we know hyperparameter tuning is quite annoying, we've been replacing the needs for having an engineer in the loop by the crowd. So we put out a challenge and we let the crowd figure out which is going to be the best combination of methods and so on, and out comes the ideal model for this problem. And so what we want now to do is to use the crowd, that is to use you, to figure out what is going to be the code for the perfect machine learning black box. So essentially, to use the crowd to replace itself. So why would the crowd do that? Well, because of some money incentive, we had some prizes for the ML challenge, famous, you would learn a lot of things, you had some fun, and you could present your results at a workshop, and finally you could realize the dream of every machine learning researcher. And don't worry too much, the problem is so hard that you're probably not going to solve it in your lifetime. We've simplified it for you. So for this challenge, we limited it to only IID data, so this means independently and identically distributed data. So this refers to data that is such that the training set and the test sets are drawn from the same distribution. We've simplified it, but we made it still a little difficult because there will be sparse of matrices, there will be a variety of types of inputs, and missing values or not, and noisy data or not, and various proportions of number of training examples and number of features. Still, it's simplified in the sense that all representations are already in the form of a feature vector. So it's a fixed length representation. So for example, if we had speech data, we would already pre-process it in terms of representing it as a fixed number of features. They will not be in this variable length time dimension. So now the output also has some variability. So this could be binary, categorical, or multi-level or regression problems. And the objective function can be drawn for a number of types of objective functions. And finally, one of the difficulties that we would like to address is to have finite computational resources. So some people yesterday in the discussion told me, well, nowadays we have a lot of compute power, so why not try all possible combinations of learning machines and choose the best one. So it's not that easy. First of all, toolkits can be huge, and potentially there is a quasi-infinite number of combinations of hyperparameters. And secondly, the training data is a finite resource as well. So if you want to choose from an infinite number of types of learning machines with a finite training data set, well, you're facing some problem of overfitting. So this is often what we call overfitting at the second level of inference. It's not just overfitting the learning machine, but it's overfitting the choice of hyperparameters. Now, I told you that we formatted lots of data sets, and we have several rounds. And then in the early phases, we use older data that we've used before, but as we progress, the data will become completely novel when people have never heard of it before, or seen it before. We chose the task to be medium hard to separate best the algorithm from the participants, and we have large data sets to have statistical significance of the results. Now, let me give you some example of how the data looked like. For example, in round 0, we had census data, so to predict the income of people. We had house pricing data, we had handwriting characters, we had text data, predict classification of text, and pharmacology data, predict the shape, predict the binding of molecules to given drug targets. So as we progress, we actually will not tell people anymore where the data sets come from, so that it will be completely impossible to get any prior knowledge about the task, and it will have to be fully automatic. We're presently in round 2, and tomorrow you'll start working on round 1. And if you get interested, you'll be able to also make submissions directly on the main challenge website on the currently ongoing round 2 and try to enter the challenge by yourself. The schedule is that after this presentation, Olga is going to do a short Python tutorial. Tomorrow we'll have more of a tutorial on automatic machine learning and on Python. Then we'll present you the hackathon and let you work for a few hours with coaches. Then after that, you'll be on your own for a few days. And on Monday, we'll have a session in which you can come and ask us questions and get some more ideas, or if you have problems, we'll debug them with you. And on Tuesday will be the day when you do your final submissions. So we'll also be available just before we close submissions, in case you have any problem. And then your code that you have submitted will automatically be executed on some test data that you haven't seen before. And then finally the results will be revealed the next day, and there will be a presentation by every group. And awards will be given to people in the form of various prizes that are going to be revealed tomorrow. You will see that the problems are not that easy. However, we will help you a lot. What's actually challenging is that you have to create a completely autonomous learner, beat the so-called no free lunch problem that says that there is no algorithm that's superior to any other for all data sets. Then you will have to solve the model selection problem, and you could be thinking of this as a meta-learning problem. That is, it's a problem in which you have to train a machine to learn how to learn. You also have to think about the problem as a two-level objective, and we'll talk more about that tomorrow. Then, you have to think about addressing learning for multiple objectives and in any possible time, so very fast and very slowly, because in the challenge we give you the data set and we give you a time budget that you don't know in advance what it is. Then it's very practically important because the industry really is in dire need of automation of data analysis, because as you know, with the increasing amount of data available and the variety of data sets, the growth of the need for machine learning cannot be matched with the number of students that are graduating every year. So we need to automate more and more. Okay, so right now we're going to get in a simple Python tutorial to get you warmed up, and Olga is going to give us the tutorial.
I was just going to suggest, just before maybe the transition, maybe there are quick clarification questions or what you just heard. No? Okay, great. Just one more thing, and then I'll go to you. So when you saw the schedule for tomorrow, the hackathon schedule starts at 10 a.m. However, we do have a talk at 9 a.m. Just wanted to confirm. Come at 9 as usual.
Okay, so I will do first basic introduction to Python today. So if you're very familiar with Python, it's the time for you to quickly disappear through the back door. And tomorrow at 11 a.m. I will do tutorial on Python and ChaLearn. So that will be actually machine learning Python stuff. So come tomorrow definitely. Okay? So I will then sit up now, and we will get started with introduction to Python. Yesterday we did instructions to set up Anaconda and zip with this IPython notebook. Does anybody have any issues with setting up Anaconda package? No? Okay, so I assume that everybody has it set up, right? True assumption? Okay, so the zip file which you get with the Python, right? There was like a geeky link, looking like this. So this link, okay? So please unzip it to any folder on your computer, okay? I'll zoom in. And then please go to the folder where you have this package. Okay, and we'll just Windows. Okay, so the resolution here is like really low, so I will just tell you what you need to do, okay? So, start your command window, please, and go to the directory where you have a package, the contents for this file. So for me, it is projects Python. And then you will have two folders. I'll show you here, right? So you have general tutorial and intro to Python. So go to the general tutorial folder in your online window. Okay? So cd to general tutorial. And then type IPython notebook. And that should start the IPython engine. Okay? Do anybody have any issues with this step at this point? Okay? So then you select this, and this is our IPython notebook. So, what is IPython? IPython stands for the Interactive Python. So, rather than typing your scripts in command window, you do it in the browser. And in IPython, you have markdown cells with the text content, and you have your code cells. Okay. So currently, just clean all the output. So select the cell, current output, and then clear everything. Okay. So, what is good about Python? So, Python it is a script language. So, it means that it doesn't do anything at the compile time. It is an interpretive language. So, as it executes something, it actually verifies if it knows the function or not. So, we will start with the hello world. So select your first code cell and then press Shift Enter. Okay? And let's execute it. Okay? Once again. Okay. So once again, Shift Enter. And you see that we've just printed the hello world message. One of the interesting things which you will notice in the Python script that it doesn't use semicolons at the end. And another thing that it uses indentation instead of the brackets to divide the blocks of code. So that's something to pay attention, and that's something which people who just start programming in Python usually have issues. So for example, if you see, this is usually the code like a C++ kind of code. So if you have brackets, in Python it will be like this. And the reason not to have brackets is that you will have the formatting erased for your code. So the designers of the pipeline decided that it's like just extra step which you can omit. So then there is no brackets to separate your blocks of code. And no variable assignment is necessary, and type is figured out at the front end. So if you need any help with the functions, so you can use the keyword help, and then what you want to have help in. So shift enter on this, and you have the built-in like help information on this function. Or another way is to have a question mark after the function or something which you want to learn about. So you should enter here, and see there is like built-in help regarding this. Or you can always use your favorite search engine and figure out what you need to do. Okay. So let's move more in details regarding variables, keywords, and strings. So as I mentioned, you don't need to declare any variable, you just start using it. And that's the beauty of Python. Everything is like very fast for the developers. And so you see, we started this a variable as an integer, and then we changed it to a string, and like this, right? But point is, please usually give more fancy name than a or x or z to your variables to avoid any debugging like nightmare in the future, right? Because you don't have time, you don't have any compilation warnings, so use this freedom wisely. So Python has a number of the keywords, which is being extended usually, and you can either see the full list like following this link, which is known today in Python 2.7, or you can run this small script to see what is the currently list of the keywords. So the keywords, they cannot be used as variable names for obvious reasons. And then like common stuff is like break, for, if, not, else, and then some other interesting things. So we will not go over everything from this list in a great detail. I picked the ones which I think are the most widely used, and we will see like how to use them. So the print keyword we've already been using. It used to print the numbers or strings or any content, and it is like useful, useful for debugging or like to see the progress of the script. So for example, let's see what this thing will do. So this prints 24 asterisk symbols. Okay. So for Boolean operations, you have to spell out or, and not. Instead of commonly used in like C++ or Java C# symbols like that. So I use I have this in space all the time. So just beware that you have to spell them out. And this is a quick sample demonstrating how to use that. Should enter. So true or false, it is obviously true. Not true, it is false, and stuff like that. So the def keyword is used to define your functions, which you will need. So for example, here we will define the root function, which will do this. Okay? Actually, it's not a root, it's like I used where, but yeah, like the choice of the name. The abstract keyword is often used for debugging purposes. For example, if we created our salary variable like variable, then we need some computations, for example, and now it is negative. But we want to make sure over the course of the script that this never happens. So if you do this, you see that it is like exploding in saying, yeah, like something is wrong with your script. Okay. Okay, strings. Interesting thing with strings in Python that they have two-way indexing. So you can do indexing like 0, 1, 2, 3 to access different charts of the string, and also there is a negative indexing. So you can index from right to left, for example. So if we take the word Python, so we can do the first character and the last character, and also we can do we can access the very last character like this, or the second last. this is the kind of example. So let's see how it's doing. So this is commonly used, and then like -1 will be n, -2 will be O. Okay. Also, slicing is supported in strings and lists. So it is a very convenient way for you to take a range of characters or range of items in the list. So this is an example of that. Okay, so this is pi, the first two characters, and if you do these ranges, then it will combine into a Python code. Any questions on this? Okay, good. So I'm moving to the compound statements, which is commonly known as if, while, and for blocks of code. So this is an example of else, of if, else, and else if. The most important thing for this to remember that you have to follow the test condition with the colon. Okay. So, for example, like this. Notice that there is a colon after your test condition, and you don't need brackets. Okay. So this is a quick example demonstrating you if you got a ticket or not if you drive too fast. So if your speed is 81 and the speed limit is 80 and the mood of the officer is bad, so this is like the options which you're going to have. Okay? So if it's terrible and you're like speeding really fast, like you will have like really big problems. If the mood of the officer is not so bad and you're speeding not so crazy, then you have a ticket. Okay? And if the officer mood is not terrible or bad, then you will get a warning. Okay, so we have 81. So this is the output. So notice, as I mentioned, you have to have colons after every test condition. And while loop is also pretty straightforward, colon at the end, and you can break out of the loop, and that's pretty much about it. Okay? So, yes?
What if I would set a column up as a break?
That's an excellent question. I think I don't do that. And that's another thing with Python. Because it is not combining anything, I can have here like completely garbage. And it will still do the same, but it will not complain if my condition is not entering into this yet. So only at the runtime it will warn me that something is wrong, and only if the code pass is actually come to this place. Okay? So for example, let's remove that. So this is, and also I give you here an example how to give, how to take a raw input from the user, like a read line in C#. So here what we do, there is like a while loop, which is decreasing the power variable, and once it is goes to 0, we will break out of the loop. Or you can interrupt the loop if you press like yes, or like once you ask it. So to demonstrate that. Enter. I think it's yeah, because I used it a couple times. Let me clear the output. Okay. yeah, I can start the whole notebook, but I don't want to do it just yet. So if you run this code, you will see that it will ask you if you want to break, and if you say yes, then it will go here and break out of the loop. Okay, let's go on. Python also supports try-catch example, try-catch blocks. So, like this example tries to open the file which doesn't exist in the current directory. So obviously, an exception will happen, and we will just handle it by printing that, yeah, there is something wrong. So let me actually see, there's like some problem to not be executing so long at this time. So what I'm going to do, I will just close this thing. Actually, I will restart the Python kernel. Okay, so it's almost there. So again. Okay, so where we were. Like that, try catch. Okay, let's see if this thing will work now. Oh, finally, yes. So you see, it got into this statement. Okay, the next thing which I want to show you is lists and tuples. So if you want to declare a list, you need to use square brackets. And in this example, I have a dogs list which has the strings, the names of the dog's breed. And I will show you a couple of common list operations which we can do with the list. So you can sort. By default, it will do for the strings the most common thing, it will do the alphabetical sorting. Or you can define your function if you want for the sorting, but it's a more advanced stuff that I should not go into. You can loop through the list, obviously, beware of this column. You can find element of the list. Okay? And this is it, okay? So let me run this piece. Okay? So it iterated through the list and printed I like all the leads pretty much. And it find the index of the holy grid, okay, which is first index, which is correct. You can append items to the list with the append function. You can insert into the particular position if you want. You can join to list just by passing them together. You can find the length of the list using the len function. And just let's see. Okay, so you see we've inserted Boxer, read, and we added a couple more to the end. Okay, and now we have 9 elements in our list. And similar as with strings, you can have slicing of the list if you need just like some range of the items in your list. So, for example, here we will take the elements from 0 to 0 and the second element of the list. And and then we iterate through them. So we mentioned that the first index is always inclusive and the last index is not inclusive. So it will take only first two elements, it will not take three of them. You can delete items from your list. So you can delete by index, or you can actually delete by value. You find this value and delete it. Okay. There's also list complications, which is a helpful function. If you need to iterate through the list and then repeatedly do the same operation on the list, you can use list comprehensions. So, for example, this is going to do the squaring of the items in the list. This example. So, tuple is another structure which could be useful. To declare a tuple, you use parentheses, and once the tuple is created, you can access the items, you can iterate to them, but you cannot delete an item from the tuple. With this, then you can do whatever you want. Okay. So functions. As I mentioned before, you declare your function using the def keyword. And for example, this is the function which will thank you, like you give it a name, and it will print a thank you statement. And you can assign the default value to your variable if you want. So, like if you pass in Adriana, it's printing thank you, like we're doing work Adriana. If you don't pass anything, it will use the default value of everyone. And this is the output. Do you have any questions at this point? Okay. Feel free to interrupt anytime if you have any questions. Also, you can have like some fancy stuff with arguments. You can use keyword arguments. You can like you see here, you can this example, right? You can give the arguments in a random order as long as you give the exact name of the argument. Okay? So, for example, in this case, we give the favorite language equal to C, right? And then we give the right argument to something. So let's do that. And here's the output. Python can also give you an option of have a function with an arbitrary number of arguments. So this needs to be the last argument, and what it will have, it will be a tuple containing all your random arguments which you get to do. But you need to put an asterisk to define this argument to collect all the variable arguments. So for example, here, you see we have two arguments in here, so it will be 1 and 2, in R1 and R2. This will now have 1, 2, and 3 here, and in this case, these 3 arguments, all of them will go to the argument tree. So you see, so this is this tuple which have all your arguments, which you all find there, and you can then have a for loop or anything to iterate through these arguments. And in case you don't provide them, like no problem, just empty tuple. So dictionaries. In their dictionary, you use this curly brackets, and you can define like key and letters in this fashion. So, for example, this is a dictionary of favorite numbers. We use person name as the key, and this is the value we need to use favorite numbers. And we can access the values using the key. And if you want to print the values, you need to use the values function. And you can print all of that. So let's find that. So here we access every favorite numbers using every as a key. Now we have a loop through all the values which we have. And then we delete Eric altogether from our dictionary. So now we have only and error in our dictionary. Python supports object-oriented programming as well. So you can have classes and you can have a base class and you can then derive from the class as well. So here is an example of a rocket class, very dummy one. So what it has, it has a constructor where we set its properties to 0, and it can move up itself by increasing its y coordinate by 1. So here's like how we create this class. This is the constructor. And this is how we call this move up method. Okay? And this is like an example of how you can create a range of those classes, and then you can iterate this with them as well. Shift enter. So this is, we printed x and y coordinates here, and this is we move up once, and this is we just created 5 of those programs, and this is basis. And we can create a shuttle class which will inherit from rocket. So this is how we create a constructor. So we'll support one more property if flight is completed for the shuttle. So this is we are calling the base constructor for the rocket class, and assigning the flights completed. Okay, so shift enter, and we are printing x, y, and then number of completed flights, which we pass as string to our constructor, and it was assigned.
What does it mean, the super?
Super, it is to call the base class, because our shuttle is derived from the rocket.
And the arguments are shuttle and self. What does it exactly mean?
That's just a syntax to call the base constructor in Python. So you have to give like the class name and then self is always your pointer to this instance. And then this is your the name of what you want to call from your base class. Okay, so looks like a little bit ugly, but yeah, it's fine. Right? NumPy arrays. So NumPy is a very widely used package for scientific computation. That's why I want to mention it here. Most of the machine learning libraries, they will assume that you use NumPy arrays for any manipulations with array or matrices. So what is good with NumPy array, I will mention the benefits done here. The main thing to remember is highly optimized for the computation. So if your if you deal just with built-in arrays or like this in Python, it will be much slower if comparing to if you use NumPy arrays. So to use NumPy arrays, you need to input the NumPy module to the script. And because you installed Anaconda, you have NumPy module already on your machine. If you don't, then this thing will not work. Okay. So we imported now the NumPy arrays module, and this is printing its version. Okay. So the main object of the NumPy is the multidimensional array. So it's like you can think about it as a table or a matrix, and all the elements have to be of the same type. The dimensions are called axes, and number of axes is called rank. So that's helpful if you reach any implementation. So, for example, the coordinate of point in a 3D space is this, right? This is our NumPy array. So the rank of this is 1 because it's only one axis. Okay. And the length of this axis is 3 elements. Okay. So for example, now we have a more sophisticated example here. So like in this we have the length of the axis, which is 3 because we have 3 elements in each axis, and the rank is 2 because we have 2 axes. Okay. So and we switch to updating base array. So this is like some useful stuff to know about NumPy arrays. So they have a fixed size integration. So if you change the size, it will actually create a new instance of this array, and it will be original. So as I mentioned, all the elements needs to be in the same type. If you can mix the types if you create NumPy array of list elements. Then you can dump some random stuff in those lists. The most important stuff that NumPy arrays, they facilitate advanced mathematical operations on the large numbers of data and very efficiently. And like lots of scientific packages, we are using NumPy arrays. So, for example, I'm referencing to the NumPy module using this syntax because that's how we imported it. If I type here something else like x, then I will have to access this by x dot and then the function from the NumPy module. So here we will generate a random array, random NumPy array, and we will get the dimensions and the size info, shape, number of dimensions, number of elements, and the type of elements. Okay, so you see, this is our NumPy array or matrix, and this is the dimensions, 3 by 5. We have 2 axes, we have 10 elements, and this is the type.
And what does it mean, the mark L? Dimensions 3L. I have no such mark in my program.
It's like depending on your settings of Python. Here, like I have more explicit type and definitions, I'll say. So it is like it is telling me that it is float, like right here. But I can turn it off. Okay, and then we can read the dimensions. There. Accessing is like pretty straightforward. just using indexes, you can get the whole row or the whole column. Okay, so this is our user element. Let's see here. So there's the guy, and then the whole row. So we are getting the second row. And then the column. So you can also transpose manually, which is useful to you. So now this is rotated. You can turn a row vector into a column vector. So that's often used in machine learning. And you can also make it into a column vector. Like if you want. So you see it's not only text, of course. Matrix multiplication is used using the NP dot. So for 2D array, it is equivalent of the matrix multiplication. For the 1D array, it will be the inner product of vectors. And for the n dimensions, it is sum product over the last axis, and the stack time is the last. So for this column, it is just multiplication. So this would be this computation of the vectors. And this is the matrix product.
Can you do micro and explain in a bit more detail?
What is light space?
No. NP dot of 2, 3. I mean, just bit of
For the multidimensional?
Input 22. That's
This one?
no, next.
No? This one?
And next.
This one?
This one.
This one? So this is scalar vector, like this is scalar product of the vector, like of the vectors.
Okay.
And this is the matrix product. So common array operations. So you can access the items like the row or the elements. You can access the whole column. Here's like I'm showing you how to get a help for the particular operation if you want to get to. For example, here, like this one, that.
But actually, it should be NP dot sum.
So here, like it is more information about the sum of a function. Okay, and so this is now the sum of the zero axis, and this is the mean of the second axis. So this is all the functions in number arrays. So for the last 2 minutes which we have, I want you to give a quick intro to the Matplotlib lib. So this is a module which is often used to visualize your data. So it is a beautiful implementation, so you to use it. So here we will, this is the plotting of the sinus function. BO means blue circles. So that you can tweak what color or like what markers or like what markers you want to use the here. For example, if I put these, now this red classes. And then this is the scatter plot points. some to random arrays, and then we define the radiuses, and then we call this close function. Okay. And this is an example of how to create an histogram. So it can also be created to random sample arrays, and then we use the different function to use it. And this is a function to plot a legend. So this is all I have for today. Do you have any more questions? So this should be enough for you to understand the sample code which was provided to you. If there are any issues with the sample code, feel free to